So today we are starting with our past paper practice for chemistry. As you can see, open in front of you is the specimen paper for the new syllabus from 2023. Right, this is for paper 2. That is the extended paper for IGCSE Chemistry 0620. You can see 02. So paper 01, which is paper 1, is the core multiple choice paper. 02 is the extended multiple choice. 03 is the core writing paper, like theoretic theory paper. 04 is the extended theory paper. Paper 5 is the practical, and paper 6 is the alternate to practical. So what we'll be doing is paper 2, 4, and 6 for the IGCSE, right? And we can even slip in some of the O level papers as well,
Yeah.
right? Now, first of all, what you want to notice, right, is because this is a specimen, it's written 0620/02 for the actual paper, which we'll come to later, right? In our practice, it will be 0620/21, for example, right? Which will mean paper 2 variant 1. So it has variants which are, depending on which zone you're in. So we are in zone 4, so that's the same zone as Pakistan, right? And so you'll probably be doing variant 2, right?
Yeah.
Okay. Uh, Always read the instructions. So you must answer on the multiple choice answer sheets. You're going to get a separate sheet like you did for the 0510, remember, for the listening paper.
Yeah.
Yeah, so you have an answer sheet for that, just like that. You'll have an answer sheet for this. Oops. So you will need a multiple choice answer sheet which will be provided to you. A soft clean eraser and a soft pencil of either B or HB is recommended. All right, the total time is 45 minutes, which is not a lot considering that you have 40 questions to answer. So the instructions, there are 40 questions, so that's 1 minute per question, and then 5 minutes to copy your answers onto the marking. So it's very close.
Yeah.
Okay, so you really have to work on managing your time. For each question, there are 4 possible answers. Choose one. Choose the one you consider correct and record your choice in soft pencil. Right, so obviously you're going to mark it on your paper first and then later going to copy it. If you're very confident of your answer, you can just mark, because you don't want to it's going to be like you need to fill in the circle on your answer sheet, right? And so you don't want to fill it in and then erase it and then fill in something else, because if it's not erased properly, then that could create problems when it's being scanned. And if there are two responses given for the same answer, for the same question, then that will basically disqualify your answer, right? So do all your working and your marking initially on the question paper itself, and then when you're confident of your answers at the end, transfer them right to your answer sheet, and just be careful that you're marking the correct answer. So for question 23, for example, make sure that you're filling it in for question 23, not 22 or 24, because that tends to happen. Right, follow the instructions. Always read the instructions, write in soft pencil, write your name, center number. So you obviously have your name since birth. Your center number and candidate number will be assigned to you in your statement of entry. Right, so fill that in. It's not given over here because this is a specimen. Do not use correction fluid. Do not write on any of the barcodes. So no writing over here, no writing in the margins where it says don't write here. And yeah, no correction fluid, so no ink erasers, no whitos, no magic whito tape or whatever, right? Total mark for this paper is 40. Each correct answer will score 1 mark. Any working should be done on the question paper. The periodic table is printed in the question paper, right? So the first thing you want to do is just take a look, right? It says this document has 16 pages. Any blank pages are indicated, right? So the first thing you want to do is you want to see, oh, do you have all 16 of them? Yes, including the blank page. So yes, you have all 16 of them, right? It also includes the periodic table over here, so you don't need to have everything memorized, right? The periodic table has your proton number, and mass number both, right? They even give you the key, the atomic symbol, atomic number at the top, and name, and then relative atomic mass at the bottom, which makes life much easier, doesn't it? Right? And they also tell you the volume of 1 mole of any gas is 24 decimeter cube at room temperature and pressure. Isn't that helpful?
Yes.
Right? So you have the periodic table here, and then you've got all these questions. So let's get to it. Right. Question 1. A gaseous substance is slowly cooled and the temperature recorded every second. The results are shown on the graph. At which point is the substance a solid?
Uh, D.
Haram?
A.
D, both of you D. D is correct. Good.
No.
Wait, you said something else?
Yeah.
What did you say, Haram?
A.
How is it a solid at A?
Like the temperature is increasing. Oh,
No,
sorry,
this
got
is this is a cooling curve. It is not a heating curve, it's a cooling curve. So it's the other way around. You're starting with a gas, it's cooling, turning into a liquid, cooling, turning into a solid, and then it stays a solid after that. Okay, now, right, so be a good job, right, but just like always read the question. Don't be in a hurry. Always read the question carefully, and every word of the question matters. Sometimes even the s at the end of a noun, which tells you that they're asking for a plural, that matters, right? So always read the question carefully, word for word. All right. A gas is released at point Q in the apparatus shown, right? Then you look at the figure that's given. So it's like a test tube or something with a cork, right? There's a gas at point Q and there's a damp universal indicator paper, right? Which gas changes the color of the damp universal paper most quickly?
Carbon dioxide.
Okay, think about it.
Okay.
Don't be in a rush, because it's our very first exposure to the past papers. We are not under that 45-minute time limit. We need to get there.
Can you explain the question?
Can I explain the question? So this is obviously experimental setup, right? And in the uh, qualitative analysis, the last chapter that we did, there were tests for certain gases, right? Now this is actually bringing in two different concepts. One is the qualitative analysis. So which gas will cause the damp indicator paper to change color? So that's the qualitative analysis part. And the other part is, right, in fact, let's look at that first. So the four options that here, right, and this is the elimination method, which is most useful, I believe, for MCQs, unless they're asking you to do a calculation or something in which you don't need elimination. You just do your calculation, and whatever answer you're getting, mark the correct answer. But normally, right, elimination works. So first of all, these four gases, would you expect all of them to cause a color change of the indicator paper, or some of them? That's the first step in answering this question.
Some of them.
Okay, so which one, Sobia, would you not expect to give a color change?
Hydrogen.
Yes, and
Ammonia.
no,
Okay. Chlorine.
no,
Carbon.
Well, obviously, like you eliminated your own responses. Yes, right? So first of all, options B and D are eliminated because carbon dioxide and hydrogen will not cause any color change.
Wait, I have a feeling chlorine will.
Wait. Walk with me, okay?
Okay.
So first of all, you're eliminating options B and D because, right, carbon dioxide and hydrogen are not going to cause any color change, right? And so you're only left with options A and C, right? In fact, the right because the option the question is which is going to indicate, right, the second part of the question is which one's going to do it most quickly. Now for a gas to travel from point Q to the indicator paper, it has to travel this distance. What factor would affect, given the information that we have, which factor will affect how quickly it reaches the indicator paper?
What?
Okay, wait, before that, how will the gas reach the indicator paper,
It will spread out
which is scientifically called what?
from higher concentration to lower concentration.
Which is called what?
Diffusion.
Diffusion. Good. Right? What is the factor from the information that we know that affects the rate of diffusion?
Uh,
Yes.
From the information that we know from this question
heavier particles take slower at the heavier particles are more,
are
heavy,
slower.
slower, yeah,
Yeah.
at a given
So we
temperature than
have the
lighter.
relative molecular mass, right? We have the relative molecular mass. And so what we're looking is for the lightest particle. Now the lightest particle is hydrogen, but hydrogen is not going to do anything, right? And so you'd be tempted to say, oh, it's going to be hydrogen. Hydrogen is going to travel the fastest. It is, right?
But it won't change colors.
Exactly.
So it's ammonia.
It is ammonia. It will turn damp red litmus paper blue,
Yeah.
right? So you're bringing together different concepts, and that's the whole thing about Cambridge papers, right? It brings together different concepts. So, right?
Ammonia is acidic.
Yes, Hara?
So like ammonia is acidic.
Alkaline,
Oh, okay.
right? Or basic to say actually, right? Because it's a gas, so it's basic. Did the approach make sense? Did it help? Yes, no, maybe.
What?
Did the explanation of how to approach the questions help?
Yeah.
Right, and so that is basically how you look at the information that's given, you look at, or you quickly recall, okay, what concepts are being applied over here. First of all, which gases are going to affect the indicator papers, then what factor is going to affect how quickly they reach the indicator papers. You look at the information, you go like, oh, it's going to be ammonia, right?
Yeah.
And if I just open up chemistry here, right, and we go to qualitative analysis. So we have, right, hydrogen is not going to do anything, right? Effect on moist indicator paper. I said carbon dioxide won't do anything, but it will, right? So it will turn it pink, and because the question doesn't say what color the indicator paper is, right? So it could be red, it could be blue. The question is which gas is going to reach it most quickly. So ammonia is going to turn it blue. It turns red, it's blue. Carbon dioxide will affect it. It's weakly acidic, so it's going to turn blue litmus paper pink, not red, right? But then even if we don't eliminate, so hydrogen is eliminated immediately. Even if we have these three options, right? The first one to get there is ammonia. Carbon dioxide will come in second, and chlorine will be last. Right? And of course, not all four of them are present over here. It is some gas which we need to identify, which will be the most quick. Okay? You guys there?
Yes.
Okay. Question 3. Which statement describes the bonding in sodium chloride?
D.
Which one was that, Haran?
D.
B. A weak force of attraction between oppositely charged ions.
Like maybe D or B.
Okay, so again, right, the elimination approach. First of all, you need to say, okay, can it be A? Right? I mean, if you recall sodium, you should know, right, immediately sodium chloride is an ionic compound. And so we are talking about ions. So only B and D are talking about ions. The other two are talking about forces of attraction between molecules, and then uh, right, sharing of electrons, which is like A is talking about covalent bonding and C is talking about intermolecular forces, and both of those don't apply, right? So A and C are eliminated right on the spot. Then you're left with B and D. Sobia, which one do you think it is, B or D? Right, she's not there at the moment, I guess. So yes, Haram, either B or D, but which one is it really? Because only one of them.
D.
It's sodium chloride. Ionic compounds have strong electrostatic forces of attraction.
Yeah. Yeah.
So it's not D, it's B. Right? Ionic compounds have strong electrostatic forces of attraction. Right? So the answer would be B. Okay. Question 4. The lead, right? And they've put it in inverted commas because we call it lead, but it's not the element lead, right?
Yeah.
The lead in a pencil. Sobi, are you following?
Yeah. I'm sorry, my
Yeah, yeah, sure,
net
sure,
was.
sure. The lead in a pencil is made of a mixture of graphite and clay. Okay, what's graphite made of? Do you recall?
Carbon.
Carbon. Okay, and clay. When the percentage of graphite is increased, the pencil moves across the paper more easily. Now, what you need to recall is, right, some of the properties of graphite that were given in the syllabus, in the text. When the percentage of graphite is increased, the pencil moves across the paper more easily, right? So it's smoother, in other words. Which statement explains this observation?
Well, eliminating method. Graphite is lubricant? No, right?
Go ahead. Like go through your process. I'll talk about it later.
Okay. Uh, Graphite is not a lubricant.
Okay. What
And
else?
And high melting point is not relevant.
High melting point is not okay. That's a good one. It's not relevant.
Uh, it is a form of carbon and graphite is a non-metal.
So which one of these two would be the answer?
B.
Graphite is a form of carbon.
Okay. Now my question, both of
No,
you.
wait. It's C. It's D.
It's a non-metal.
Yeah. No, wait. Yeah, it's an ornamental. Okay.
So it is a non-metal. It is a form of carbon. So they're both correct.
So B and D could be both correct
No,
answers.
no.
Okay.
They're both incorrect. I mean, the statement is correct. Graphite is a form of carbon and graphite is a non-metal. The statement is correct, right? But in terms of answers, both B and D are wrong.
It's a lubricant because it is moving smoothly.
Exactly.
Yeah. Okay.
Right now, your first instinct was, and so that is to revisit the concept. What do they mean by lubricant? For us, lubricant is a liquid, right? So oil, maybe grease, right? Stuff like that. Generally speaking, a lubricant is anything that helps smoothen movement. It reduces friction. And if you recall the properties of graphite, I'm not going to like keep going back to the text, but if you recall the properties of graphite, it's made in layers, and those layers can move over each other. And that's basically what's happening in a pencil, right? The graphite, the top layer, which is in contact with the paper, it is moving, and that carbon is being left behind on the paper, which gives you the black or gray writing on the paper, because you're leaving carbon on the paper in your handwriting in whatever language it is, or numbers, or whatever you're doing. And so the reason why it's smooth is because the layers of graphite are moving over each other, right? And so that movement of the graphite is, you know, a lubricating, like the property is lubrication. It's not a liquid, obviously, right? It's not grease, it's not oil, right? But it is a lubricant in that sense. So it's actually C. Because, right? So again, just because an option seems like it's true, fine, right? Graphite is a carbon, a form of carbon, it's a non-metal. They're both true. But in context to the question, does it make sense as the answer? The pencil moves across the paper more easily because it's a non-metal. That doesn't make sense, right? That would mean that if you've got like some other non-metal, such as, I don't know, silica, like sand, right? And like silicon is a metalloid, so right, you've got like this is, yeah, sulfur, right, or phosphorus, and so that would make it smooth as well, and obviously that's not true. Okay, get it? So moving on to question 5. Which statement about metals is not correct? Right? Not correct. So here you want to eliminate the ones that are correct. You're looking for the wrong answer, like the wrong statement.
Okay.
Don't be quick. Just read each and every statement carefully, and then, right. So phobia and Haram both, right? They conduct electricity because delocalized electrons can move throughout the metal. Is that true or false?
False. Wait. False.
It's true, beta. Right? They conduct electricity because they have the delocalized electrons. Remember metallic bonding, right? So you need to revisit metallic bonding, right? You've got metallic atoms with delocalized valence electrons, and those delocalized electrons are what help it conduct electricity. Okay, they consist of layers of atoms that can slide over each other. True or false? Haram says 2. Sobia?
Well, metals are hard, so wait.
They're hard. Well, I mean, relatively speaking, right? Some metals are soft in terms of being metals, but right, properties of metals include them being malleable, which means that they can be made into sheets, which means that right, they have layers of atoms that can slide over each other. That's why you can make sheets out of them. I mean, not just sheets, but they can be made into different shapes. They can be hammered into shape,
Yeah.
right? So
Okay.
B is also true. C, they have a giant lattice of oppositely charged ions in a sea of delocalized electrons.
False.
This one is clearly false because, right,
Yeah.
giant lattice, yes, but oppositely, like so the metal structure has both positive and negative ions. That is not true. But before we come to an answer, let's look at D as well. They have a giant lattice, so that's the same as C, of positive ions in a sea of delocalized electrons. So we've already established that they have delocalized electrons. So that's true. They're positive ions. So we know metals lose electrons. And by losing electrons, they make positive ions. So that is true,
Yeah.
right? And so the incorrect statement is C, which is in this case the correct answer because they're asking for which statement is not correct. Okay?
Yeah.
All right,
Yeah.
this should be an easy one. Uh, aqueous iron 3 sulfate and aqueous sodium hydroxide react to give a precipitate of iron 3 hydroxide and a solution of sodium sulfate. Which one of these is the balanced equation for them?
See?
Haram? Haram, any guesses? Right, so Soviet C is correct. And all you need to do is just count the number of atoms or like entire groups on each side. Right, so you've got 6 of sodium here, and you've got 3 times 2, 6 of sodium here. You've got 3 sulfates here, you've got 3 times the sulfate. So you've got 3 of them over here. Then you've got 6 oxygens and 6 hydrogens, right? Or OH actually, you've got 6 of the OH, and so you've got OH times 3 and then times 2. So 2 times 3 is 6. So you've got 6 of the OH over here and then 2 of the Fe here and 2 of the Fe here. So it's balanced. Right, so you quick on that, so be a good job. Question 7. Which information is needed to calculate the relative atomic mass of an element?
See?
You sure?
Yeah.
Which one did you say, Sobia? Sorry, Haram? B. D. Okay. So the difference between C and D is mass number and atomic number. If you just go to the periodic table that they've given us, right, atomic number is basically the number of protons that they have, right, and relative atomic mass, which is given at the bottom, is right the number of protons plus neutrons. So, right, we know that isotopes are variations of the same element, which means they'll all have the same number of protons. So you're not going to get any information from that. So what you need is the mass number, where you have the number of protons plus number of neutrons, because what makes an isotope is the different number of neutrons in the nucleus of the atom.
Because neutrons and protons are the same.
They're not the same. They have the same mass, and so together they make up the mass of the atom. So
Yeah.
option C is correct. You need the mass number of, like, for example, you've got hydrogen, deuterium, and tritium, right? So hydrogen on its own has no neutrons. Deuterium has one neutron, and tritium has two neutrons, right? All three of them have a single proton, because it is the number of protons which defines which element it is, right? So you can't go around changing the number of protons. If you change the number of protons, you are doing nuclear reactions, which you don't want to do. Okay.
Yeah.
And the abundance of each isotope. So yes, right, what's the mass of each isotope and what's the abundance, and they've given the formula for that, right? Which chapter was it? This one. Do they talk about isotopes here? I forget where exactly it is. Isotopes, yes. So yeah, there was a formula for this, for the abundance. Do you remember when we came across it?
Wait. Somewhere it was somewhere in the atom chapter. Check. Can you check the elements?
The periodic table?
No, the 2.1 chapter. Can you check there?
Yeah, I'm just backtracking. So here's the beginning of the chapter. Uh, can't seem to find it right now. So we'll take a look at it. I mean, I'll see if I can locate it later. You guys do that as well. Okay. Oh, here it is. Abundance. So, right, you multiply the percentage abundance with the mass, right? You add up each one of those individually, and then you divide by 100, right? And that gives you the average mass of that element, taking into consideration all the different isotopes. Okay, so chlorine 35 has 75% abundance, so that's 75 times 35, right? Plus 25 times 37. You add those two, divide by 100, and you get 335.5. Right, so that's option C. Now, one thing that gets students worried for some reason is if you get the same answer, like the same option as the answer repeatedly for a number of questions, they're like, there's something wrong, right? Just if you notice question uh, 4, 5, 6, and 7, so that's four consecutive questions, right? So 4, graphite is a lubricant, right? The oppositely charged ions is the balanced equation, and find mass number. You've chosen option C for all four of them, and option C is the correct option, right? So when you see that on your answer sheet and you're like, all four of these have the option C, right? And the four consecutive questions that have C as the answer, there's something wrong. No, there's nothing wrong. You need to be confident in what you're doing. Okay?
Yeah.
Okay, question 8. The equation for the reaction between sodium carbonate and excess dilute hydrochloric acid is shown over here. Here, so you've got sodium carbonate and hydrochloric acid giving you sodium chloride, water, and carbon dioxide. Oh, moles, right? So when 26.5 grams of sodium carbonate react with excess dilute hydrochloric acid, what is the maximum volume of carbon dioxide produced? Right? What do you need to do to answer this question? And this is a calculation question, so you need to be quick about it.
Yeah.
Aram, your voice is like very mumbled and garbled. I can't make sense of it. Sorry. You could speak up a little.
Concentration equals the number of moles divided by volume.
You're not looking for concentration. The first thing you want to do, right, is
Calculate the molar mass.
right. First of all, you take a look at the mole ratio between sodium carbonate, and
And carbon.
they're asking for the volume of so what's the mole ratio between sodium carbonate and carbon dioxide?
Well, Na is 23.
What's the mole ratio
Oh, okay.
between sodium carbonate and carbon dioxide? 1 is to 1, right? 1 mole of sodium carbonate will give you 1 mole of carbon dioxide gas, right? So that's the first thing you want to establish. And we're doing this like in a paper, you'll be doing this quickly, obviously. Because the calculations tend to take a bit more time. Next step is, right, you get the relative molecular mass of sodium carbonate, right? So Na is 23. So again, going to the periodic table, and you take the values as they've given, right? So sodium is 23, and so it's Na2CO3, and so right, you want to do 23 times 2 plus what do we have for carbon?
12.
Right, over here you've got 12 and O3, and so oxygen is 16, so that's 16 times 3, right? And that's 106. Is that what you're getting, Soviet?
Just a minute. Yes, yes, yes.
Right? Now what you want, so the MR of sodium carbonate is 106. Now what you've used, saying that 106 grams is 1 mole, right?
Yeah.
And so, right, how many moles is 26.5 grams?
How many moles is right?
20, the mass that's been used, 26.5 grams.
Yeah.
How many moles is that?
Alright. Just a minute. We gotta divide, right? 26.5 divided by 106.
Yes,
That gives us 0.25.
it gives you 0.25, right? And then because because the mole ratio is 1 is to 1,
Mm.
0.25 moles of sodium carbonate will produce 0.25 moles of carbon dioxide.
Yeah.
Yes?
The ratio is balanced, yeah.
Yeah? So, right, carbon dioxide is a gas, and so it's measured in terms of its volume. 1 mole of a gas gives you 24 decimeter cube, right? So what will be the volume of 0.25 moles, right? So you basically multiply 0.
We are finding molar volume, right?
Yes,
Okay. So we're gonna multiply
multiply what?
0.25 with uh 24,
Yes,
and you're gonna get 6 dm3
and so which one of these options?
is A.
Obviously, right? And so this is one of the questions where you don't need elimination, because you do your calculation and you just get the right answers. You're not even considering any of the other, right? Because your calculation is telling you it's DMQ.
Yeah,
Okay, that was fun,
yeah.
right?
By the way, just to clear up, we multiplied by 24 because
We do.
one mole of gas occupies 24, right?
Yes, and you are producing 0.25 moles of carbon dioxide, and so obviously it will produce it will occupy less volume, and that's exactly what they're asking you. What is the maximum volume of carbon dioxide produced,
Okay.
right? Which obviously means that if all of the going back to stoichiometry, right? Assuming that this is 100% pure and this is 100% pure, and all of them react, and you're getting 100% yield of carbon dioxide. So 0.25 moles of sodium carbonate will produce 0.25 moles of carbon dioxide gas, right? I'm sorry, Haram. I really can't understand what you're saying. Could you type it out, please? Yeah, so 24 dm cube is only used for gases because it's volume, right? So gases are measured in terms of volume generally.
Per
Okay,
mole.
per mole, yes. So the more or less moles you have, the volume will obviously be accordingly.
Yeah.
Okay, let's try to do at least up till question 10. That's 1/4 of the paper. Electrolysis is coming up. Okay, so question 9. A volumetric pipette is used to measure 25 centimeter cube of 2 moles per decimeter cube aqueous sodium hydroxide into a conical flask. So over here, right? A burette is filled with dilute sulfuric acid. The equation is shown here, right? So you have 2 moles of sodium hydroxide reacting with 1 mole of acid. The reaction requires 50 cm cube of dilute sulfuric acid to reach the end point. What is the concentration of the dilute sulfuric acid in mole per dm cube?
Could you like zoom out so I can look over there? Look over the picture.
Just a sec. Can I zoom in a bit? Yeah, just.
Uh, are we gonna calculate the moles here?
No. The very easy and quick method. Remember, I gave you that, it's also in the book. So, moving to the whiteboard very quickly. Erase the recording. There we are. So there's the whiteboard. So what you want to do is, all right, C1 V1 over M1 equals to C2 V2 over M2, where C is concentration, V is volume, and right, volume in centimeter cube, and M is moles as per chemical equation, right? So we know everything about sodium hydroxide, so let's take that. The concentration of sodium hydroxide that they've given is 2 moles per decimeter cube. So that's 2 times the volume in centimeter cube, so that's 25 centimeter cube. And the number of moles according to the chemical equation is 2 NaOH upon 2. Right? The concentration of sulfuric acid is unknown. The volume is 50 centimeter cube, so multiplied by 50. And the number of moles in the equation is 1, right? So it's 2 NaOH plus H2SO4, so just 1 mole of sulfuric acid. So you've got 1, right? So changing ink, this cancels out. And so basically what you get, X equals to 25 over 50, which gives you 0.5 mole per decimeter cube. Do we have that option?
Yeah, we do have that.
Alright, so going back to the paper, this is just the one thing I find annoying about NEET is trying to keep resharing the screen. Alright, and it's option A,
Yeah.
right? And that is your answer. So the quick formula for solving titration equations, like problems, is like if you go step by step or number of moles and then convert that and then do
Does
that,
not take time.
that's going to take a lot of time, right? And so the quick way is what you want to do. Haran,
Yeah.
did you follow?
Yeah, and I did that try that one from here. More so that we can see.
Uh, if you could type that, if it's a question, if it's a comment, I'll just let it go, right? And if you can, like, do something about your mic, if you can. All right. Question 10, last question for the day. The diagram shows a circuit used to electrolyze aqueous copper to sulfate, right? And they've numbered it 1, 2, 3, 4. So which arrows indicate the movement of copper ions in the electrolyte and of the electrons in the external circuit?
Mm-hmm.
Okay, now let's take a look at this. So
Yeah.
first thing they're asking is movement of copper ions. Are copper ions positively charged or negatively charged? Positively charged, right? And so will they move to the positive electrode or the negative electrode?
Negative?
Negative, right? That's the cathode, right? So for the copper ions, we've got 2,
Yeah. Proper answer. That's it.
right? So that means that A and B are both out.
Wait, is it D? Is it?
It's not.
It's not D.
No.
Okay.
Acha. Electrons in the external circuit. So electrons in, like, a bit of physics over here. Electrons in the external circuit move from the negative terminal to the positive terminal, right? So in this case, see what's happening at the cathode. The positive ions are moving towards the cathode, and they're gaining electrons. The negative ions, right? So, right, the negative ions will move towards the anode and they'll give up their electrons. And so the anode will take those electrons and those electrons will move towards the positive terminal of the power supply.
Yeah.
Right? And so that gives you C. The copper ions are moving towards the cathode. Right? The cations, so the cations move towards the cathode. And the electrons are moving towards the positive terminal because electrons flow from negative to positive. Right? And also like the if you take a look at from the perspective of anions move to the anodes, right? And they give up the electrons, and obviously so it flows to the positive terminal. Okay,
Yeah.
make sense?
Yes.
Right, so a slow start, but that's good, right? And so we'll continue this tomorrow, inshallah.
So what's the correct answer?
C.
Why isn't it D?
No, again, देखो, for the copper ions, we established that it's moving towards the cathode, so that's done.
Aren't cop okay.
The cations will move to the cathode, right?
Yeah.
So that's 2.
Yeah.
The electrons in the circuit, the electrons move from the negative to the positive terminal. So the flow is from the negative. So this arrow should actually, like if you're making the proper circuit, this arrow should be pointing downwards at number 4, right?
Yeah.
And yeah, but it's not pointing downwards, pointing upwards, right? It's saying that the electrons are moving towards the negative terminal of the supply, and that's not what happens. Remember,
Towards the cathode?
electrons in the circuit, not at the electrodes.
Okay.
Where are the electrons coming from? What's happening? The power supply from the negative terminal is supplying electrons. It's coming down, not up. So this is wrong. This is wrong. The electrons are flowing towards the cathode. The copper ions, which are
The
positive.
diagram is written wrong, which is why okay.
Yeah, so the diagram's there to trick you, right? Don't assume that this is correct. Only 2 of these are correct,
Okay.
right? So the electrons are coming in from the negative terminal. They're going to the cathode. This is where the copper ions are collecting. So they're gaining electrons from the cathode and they're turning into elemental copper and they're depositing over here. The anions are negatively charged, means they have extra electrons, so they're going to the anode. They're giving up their electrons. The electron will flow in the circuit towards the positive terminal. And even if you recall physics, right?
Yeah.
Physics, they told you that electrons flow from the negative to the positive, right? That's how it happens. Because
Okay.
electrons are negatively charged, so they're going to flow from negative to positive,
Yeah.
right? So that should be like, that should be straightforward. Okay,
Okay. Yeah.
right. So see you guys tomorrow.
Yeah.
All
Okay.
right.
Allah Hafiz.
Allah Hafiz.